Okay, so this is the question you sent me. And you said you were wondering about the yhats. So a yhat is a Y with a hat on it. But when you type it in here, I just type it like that. It's easier than trying to put the symbol over the Y. But what it actually is, it's the estimated Y value. And so what you need to do is find the regression equation. In this problem, you were already given the regression equation, but I'm going to show you how you can actually find it if you're just given the data too. So what we're going to do is we're going to go to Insert, and then we're going to select the data, click Scatter Plot, and now that's the dots that represent these pairs of data where the year would be X and the retail sales would be Y. So the retail sales are across the axis, and I meant to say it the other way around. The years are on the horizontal axis, and the retail sales are across the top. All right, so now to find the regression equation, we're going to do just click on the dots, right click, and then go down to Add Trend Line. So we want to make sure it's selected on linear, and then you want to come down and click Display Equation and Display R Squared. So now I know what my correlation is 0.996. So that describes the percentage of retail sales, or the changes in retail sales, that can be explained by the year. But if I take the square root of that, I'll get my correlation coefficient, which measures the strength of the line relationship between the two variables. So I'm going to use the square root function. And select the R squared. Okay, so now if I was trying to figure out how strong the correlation is, I'd be able to do that using this value and comparing it to a critical value from the table of R values. Okay, now if the correlation is strong enough, close to 1, close-ish to 1, close enough to 1, depending on your sample size. So that's what your table is for, is looking up whether it's strong enough. This is really strong because it's very close to 1. Also, if it was negative, we would want it to be close to -1. So that looks really close. And then if we want to estimate the yhat, what we're doing is we're saying, well, here's the actual dots, right? And then the trend line fits those dots the best possible way using the least squares regression method. And the is going to predict a different value than the actual retail sales in this column. So what we do is we take the X value times the slope, which is 9.4396. Okay, then we add the y-intercept, 84.182. And you can see that when we use the equation, the line, it estimates that the retail sales for year 0 should be 84.182. I think they were thousands, or I don't remember actually. Let me look at that question you sent me again. Okay, you see how it says here, they give you the equation right there that we just found ourselves. And they say that it's the retail sales in T years since 1995. Okay, and then it says use the above scatter plot to decide whether the linear model fits the data well, and the scatter plot did fit the data really well, or the trend line fit the scatter plot data very well. So we would look at that, look at the strength of the linear correlation and the strength of R squared and say, yeah, this looks like a good model. So I'm going to plug in my X values to make predictions. Now, we were specifically asked in this question to estimate the retail sales in 2011. And 2011 is how many years after 1995?
16.
So what we would do is we could do y hat, and we can put in the same thing we did before. Basically, we put in the y value, or excuse me, the x value of 16 years since 1995, times the slope 9.4396 plus the y-intercept 84.182, and press enter. And so that should be the answer there, rounded to whatever you're asked to round it to. Okay, so, and then it says use the model to predict the year in which retail sales will be 230 billion. Use the model to predict 230 billion. So far, did that make sense what I just did there?
Yeah, kinda. It made more sense than what I had before.
Okay. And now to do the estimation the other way around, we might need to be a little creative because it's like you're working in reverse. You're using this equation to actually find x. So right now the equation is solved for y, so that when you put in an x value, you'll get a resulting y value. But what we want is x the year. So what we can do is we can solve this equation for x. Do you remember how to solve an equation for a variable from algebra?
Yes.
Okay, so what's the first thing you would do here?
Subtract 84.182.
Yes, so y minus 84.182. And then what would you do next?
Divide 9.4396 by both sides.
Yeah, so we're going to and divide it by the coefficient of x, 9.4396. Okay, so that's what we're going to do in order to get x. Make sense so far? Okay, so now we're actually, so I'm going to do equals, then parenthesis, and the y value that we were asked to use, the retail sales, was 230 billion. And all these values are in billions, so we're just going to leave it 230, representing 230 billion. Then minus the 84.82, those parentheses, divide by 9.4396. Enter. So then 15 years after 1995, right? So 1995, 15 years after that would be 2010, right? 2010, but then we're into the next year. So the answer should be, I think, it would be 2010 because you're still in the year 2010. Yeah, it should be 2010. So 1995 plus 15 years.
Yeah.
Or does that make sense? I think you have to be, nope, the answer would be 2011 because by 2010, you would be at exactly 15 years. But we have to go more than 15 years. We have to go almost 15 and a half years. So this actually should be the final answer right there. So this was the answer for the first one. That was estimating retail sales based on an X value. And this one is estimating a year based on a Y value.
Okay, so I think I understand most of it now. I kind of don't understand still the R's, like how you find the R's.
If you're trying to calculate it by hand, like I did in the one video that I assigned,
Mm-hmm.
you have to follow all those steps. But I'm not going to require you guys to do that for the test. I just wanted you to try it for the experience of learning how to use Excel and
Oh,
just so that you understand sort of where that number comes from and how it's calculated. But I don't want you to do all those steps on the test. All I want you to do for the test is if you're asked to calculate R, I want you to use this method right here and then take the square root of R squared.
okay. So the test is not necessarily how to solve everything, but kind of just making sure that we know how to use Excel.
Yeah. So different ways to teach statistics. One way is you can have the students really do all the formulas. And another way is that you can focus more on understanding and knowing which methods to use and trying it with available technology. So I'm doing a little bit of both in this class, but for the test, I'm mostly wanting you to be practiced enough with the technology that you know what to do and how to get it.
Okay, that makes sense.
Good. You feel better about this one? So is there other stuff?
Let me go back to it because I accidentally clicked out of it. There was hopefully